Welcome to Development Victoria's presentation outlining the options considered for our Knoxfield wetland proposal. My name is Peter Hood, a Senior Director from the Property Group, having worked with Development Victoria for 6 years and delivering many residential developments with established water bodies, similar to what we're trying to achieve at Knoxfield. As we are the Victorian Government's property developer, the site gave us a great opportunity to deliver diverse and affordable housing in the Knox municipality. Before we purchased the Knoxfield site, Knox City Council identified the land for residential development as part of its strategic planning. We ensured the project's incorporated plan within the Knox planning scheme is based on Council's original plan, which includes the repurposing of the existing man-made dam on site. In relation to Development Victoria's proposed wetland, our first step was to review Dr. Lorimer's report. Unfortunately, this report largely focuses on ecological outcomes, whereas Development Victoria needed to consider a more balanced outcome that addressed all other aspects associated with a large residential development such as this. Yes, of course, we needed to consider the ecological outcomes. They're very important to us, but we also needed to consider site safety. Development Victoria takes this very, very seriously across all of our projects, and we do not and will not compromise. This meant we did need to consider the steepness of the dam's embankment, the depth of the water body, and the dam's structure and functionality, along with the condition of the dam's outlet. We needed to consider stormwater management. The current dam is not delivering stormwater management in line with current best practice. We also needed to consider the requirements of governing bodies, including the state government, Melbourne Water, Knox City Council, who will ultimately be responsible for the wetland itself. We also needed to consider future residents, along with existing neighbouring residents, their wellbeing and their recreational needs. With this in mind, we obtained advice from expert ecologists and hydrologists to review the man-made dam and the options available. We asked them to consider community safety, the ecological environmental contribution of the dam, and other functional attributes required by the development. We began with how we might keep the dam in place without redeveloping it. Secondly, we looked at how we could fix the current dam. And thirdly, we looked at how we could improve the current dam with consideration and balance to all the aspects we needed to consider from the environment, safety, and community. From the beginning, it was clear that we could not deliver option one, which is to leave the dam as is. We could not simply fence the dam without treating the stormwater. It was also evident that to fix or to repurpose the dam would require the dam to be drained and its exposed surfaces reworked. This, of course, would be catastrophic to the dam's ecology. Because of this, we identified the third option as the most appropriate. The third option will address the safety requirements appropriately, manage the stormwater and meet local authority requirements, improve the breeding habitat of the blue-billed duck and other wildlife, and to provide an improved recreational asset for the wider public. We believe our wetland proposal appropriately addresses each of these important elements. Glenn Ottrey, Development Victoria's appointed hydrologist from Engineer Water Management, will now illustrate in more detail the options we needed to consider for the proposed wetland. Thanks, Glenn.
Thanks, Peter. As Peter mentioned, my name's Glenn Ottrey. I'm a Principal Environmental Engineer at Engineer Water Management, and I've been working on this site since 2016. So the role that Development Victoria has asked me to fill and to provide advice on is how to develop this site and what they need to do in terms of treating stormwater and managing stormwater. So their key goals are, from a stormwater management point of view, to treat the stormwater to best practice environmental targets as set out in the planning scheme, and also to not increase peak flows or flooding with any of the development on the site. So this is a figure that shows the topography of the existing dam, and the warm colours are showing the higher elevations and the colder colours like blue showing the lower elevations. So you can clearly see the dam wall here on the western side of the dam, and it shows that the dam is about 1.5 to 2 metres deep in the majority of the areas, and that there's a little corner pocket in the bottom here that's about down to 4 metres deep. You can also see Blind Creek to the north and the inlet drain where it comes in to the south. The existing dam is currently in poor condition and it has a few issues that would need to be rectified if it was to be kept. So one of the key issues is that it doesn't have an adequately sized spillway. The spillway is the structure that lets water flow out of the dam in a manner that doesn't damage the dam wall. So it's usually in the form of concrete or rock lined chute or structure that water can flow over. There's some evidence from the site of, this is the downstream end of the wall, the dam wall in the top north corner here. And this is showing it on one of the site visits I attended. And then this is showing the same area 9 months later. And it shows significant erosion through here. And what's happened is water has overtopped the dam wall from either Blind Creek or the dam itself and has eroded back through this area. And you can see it's quite significant erosion and it's actually working its way back from Blind Creek up towards the dam wall. And if it reaches the dam wall and gets back into the dam, the whole dam will actually drain through this hole, and it could potentially happen quite quickly. And if it does, then that's a significant safety risk. If it does it slowly, you just end up with a dam with no water in it. In addition to that, there's issues of erosion from wave action on the embankment here. And there's also some the issues with erosion up here on the embankment. To fix these issues, including installing a proper spillway, would require emptying the dam or at least lowering the water level significantly. And the civil works would have a significant detrimental impact to the water quality in the dam if there was any water left. Another issue that Peter touched on was the safety associated with the dam. So this image also shows that the dam currently has quite steep batter slopes, so the slopes on the side of the dam. And we've had a bit of a look at what sort of area of the dam would be impacted if you tried to flatten those batter slopes out to the guidelines that are recommended by the Royal Lifesaving Society of Australia. So they recommend that when you get to the water level of a large water body, you have what they could describe as a bench, which extends out into the water body at a relatively flat grade. That means that if someone falls into the dam, they can land on this bench, which is actually just dirt, mud, given that it's underwater, and then scramble back up out. At the moment, if someone fell in, it's a fairly steep slope they fall into, it'd be quite difficult to get out. So if you were going to regrade the inside of the dam embankments, this is the area that would need to be regraded. So this ends up being about 40% of the total dam footprint, which is a pretty significant impact given that you're essentially having heavy machinery placing earth on this area. You'd also need to have access through this area to be able to place the earth in this area on the north because there's a bunch of remnant vegetation that we're trying to retain. This would require the dam to be drained completely and would obviously have a pretty severe impact on all the plants and animals that are currently using the dam. So we've had a look at some other options to manage stormwater on the site. I just want to show this figure first here, which shows the flooding associated with Blind Creek, because this helps to give a bit of context for the natural topography of the site. So this is showing flooding in a 1% annual exceedance probability storm, or a 1 in 100 year. And you can see that there's a part of the floodplain down here that engages with the creek that's coming through here. And you can also see that water gets into the dam and then overtops the embankment and floods the downstream industrial area. So this area here is actually low lying on the site and somewhat connected to the river system anyway. And this area up here is sort of higher up and being filled above the floodplain level. So one of the options we had a look at was to put a wetland in the area that's currently flooded by Blind Creek. So this is down on the floodplain of Blind Creek. So this would be a stormwater treatment wetland to help orientate with this one. The red lines are showing property boundaries. The orange line is showing the existing dam, and the dashed red lines are tree canopies. So this proposal is for a sedimentation basin here and then a wetland here. So water would flow into the sedimentation basin, into the wetland, and then out. This would also let you meet your pre-developed flow targets, so do some retardation on the site. The key problem with this proposal is that you end up with a water level in this wetland and sedimentation basin there's almost 2 meters lower than the dam. So you want to try to provide treatment of stormwater before it flows into the dam to help remove pollutants to improve the water quality in the dam. So if you divert all the flows into this wetland and sed basin first, you then have to pump it back up into the dam to keep water in the dam on a continuing basis. So this creates a really significant ongoing cost in terms of running the pumps, but also maintaining them and keeping them working. It's unlikely council would want to take on this option. So we had a look at another option, which was, can we sandwich a wetland and sedimentation basin in between where water flows into the site and before it gets to the dam? So again, on this figure, the orange boundary is the existing dam, red boundaries are property boundaries, so the red lines are property boundaries, dash red lines are trees. And so this is the key inflows to the dam are for a drain that exits the school somewhere around here, and it goes into an open drain. So there's a pipe into an open drain. From the bottom of the pipe here, where it enters the development site down to the dam, there's about 300 millimeters of total fall between the bottom of the pipe and the water level in the dam. So there's not very much vertical space to play with there. So it's a pretty narrow sort of a window that you can vertically, that you can put this asset in to have water flow into it and then flow out of it under gravity. So a proposed sedimentation basin could go here and a wetland here. This is up on the higher area that's not impacted by the flooding in the floodplain from Blind Creek, because given we're trying to keep this all high, we need the water sitting at a similar level to the dam. That means that if we build anything in this area, we have to fill the floodplain, and that'll cause problems from Melbourne Water's point of view in terms of loss of floodplain storage associated with Blind Creek. So we can't really push this shape much further out into this area. A key drawback of this proposal is that you end up needing a fairly significant levee around the edge of the wetland and sedimentation basin to be able to achieve the retardation goals that we need to meet, so that we don't increase flows being released from the site. This ends up being almost 2 meters above the normal water level in the dam. And this creates some other problems too, in that if you got a 1% AEP flood, this shows roughly the extent of the area that would be flooded. So it's showing that obviously the sedimentation basin and wetland get flooded, but also the flooding goes back onto the school site. And this is because overland flows will be coming through the school site and also out of the pipe somewhere around here. And it'll build back up until it reaches such a level that it ponds back onto the school site. Now, this outcome wouldn't be acceptable to the school or to council, and it's not reasonable to flood another property as part of this development. The neighbouring properties here have already been filled quite a lot, so they're not impacted by flooding under this scenario. So we then come to the preferred option that we've come up with, which is for a sedimentation basin, treatment wetland, and then habitat wetland. So under this scenario, the low flows are piped from the outlet, which is down here somewhere, through into the sedimentation basin. They receive treatment in there before passing through into the treatment wetland. So the sedimentation basin takes out most of the coarse sediments. This would be a largely open water body. It then moves through to the treatment wetland, which would be a largely vegetated area, so 80% covered by reeds and emergent macrophytes, they're known as, so wetland type plants. This will remove the fine sediments and also most of the nitrogen and phosphorus from the water. And then we've proposed a large habitat wetland here, and this would have vegetation around the edges of it to provide habitat for the water birds and also provide some additional treatment that we're not actually claiming any benefit from, and then be largely open water in the middle to help mimic the existing habitat of the dam. So under this scenario as well, the maintenance of this asset can be undertaken into the future without disturbing the habitat wetland. So the sedimentation basin will need clean-out works roughly every 5 years once development is complete. And the treatment wetland would also need to be reset roughly every 25 years. And reset effectively means get an excavator, dig out all the sediment that's accumulated in it and most of the plants and replant it. However, with the design we've proposed, you'd be able to keep the habitat wetland full of water while all this is happening, and it should be largely undisturbed. And given that there's quite a lot of pre-treatment happening before water goes into the habitat wetland, we would expect that the habitat wetland should not need significant ongoing maintenance beyond just litter removal and that kind of standard thing. So this is the option that we've put forward, and those are the reasons why. So I might throw it back to Peter now. Thanks.
Thank you, Glenn, and thank you for listening to the options Development Victoria needed to consider when developing the proposed wetland. We look forward to working with the community and key stakeholders as this exciting project progresses. For more information, please head to the project website or email.